Hello, this is Mr. Henry, and this is lesson 3.6, solve proportions using cross product, which if you were here for the last lesson, that's what we did in every single problem. So this is basically just more practice of the same old thing. Essential question, how do I solve proportions using cross products? Simple enough. Let's look at these two get the goofs and see if there's any mistakes. Well, first thing I see is there's no labels. There's nothing to tell me what that 15 means or that 3. So let's look. King Kong can eat 15 bananas in 3 minutes. So if we have bananas, bananas, minutes, minutes is how it should be. How many bananas could he eat in 15 minutes? Whoopsie. That's why this is wrong. This bananas should be the variable, and it should be 15 minutes, which means the whole rest of the problem is probably wrong. So let's get rid of him and do it ourselves. So we have 15 times 15, which I think is 255. 15 times 15, 225. That was close. 225, that's this times this. And 3 times x is 3x. Divide by 3 to cancel. Divide by 3, and x equals 225 divided by 3. It goes in evenly, but I don't know how many times. Divide by 3 goes in 75, and the label would be bananas. So in 15 minutes, King Kong could eat 70. Ooh, I put 2. 75 was the answer. 75 bananas. Number 2, again, there's no label, so it might be correct, but I don't think so. Train can travel 230 miles in 2 hours. Well, first off, automatically that's wrong. This hours is over here. My labels don't match up. This 2 is in the wrong spot. This 2 should be down here. So this whole thing, garbage. Gone. Let's do it right. 200 and garbage. 230 miles over 2 hours. Miles, miles, hours, hours. How long would it take the train to go 1,000 miles? Well, we know that's 1,000. We do not know how long, so that's our variable. Cross multiply here, we get x times 230 is 230x. 2 hours times 1,000 is 2,000. Divide both sides by 230. Divide by 230. These cancel. X equals 2,000 divided by 230. 8.66, we'll call it. We're rounding that up to the nearest hundredth. So 8.66, and my label was hours. So that's setting up a proportion and solving the proportion. So we got some of the same vocab words, or words we looked at even yesterday. Cross product. Cross product is the product of a number of one ratio and the denominator of the other. So that's saying you multiply the diagonals. Yeah, got it. Scale drawing. A scale drawing is a drawing that is proportional to an actual object. So when you see a scale drawing of a race car, for example, or a building, if you have your actual Eiffel Tower, that's a sweet Eiffel Tower. So if you have your actual Eiffel Tower, the scale drawing should look exactly like the real Eiffel Tower. You wouldn't have one that's like really tall and skinny like this because it's not the same. They're not in proportion. This one's much skinnier than that one. If it's actually in proportion, yeah, one will be bigger than the other, but it should look the same. So I'll do my best. Of course, I did a horrible job drawing that there. That's pretty close. So these two things you might say are in proportion. A scale model, well, same thing as the drawing. It's just a model that is proportional to an actual object. So if you go to, if you buy like a Matchbox car, a race car, that would be a scale model because everything is the same size in proportion. So the wheels compared to like the hood of the car. What the heck is that? It's like a bug or something. It's not even my normal ugly car. There we go. So there's one car, and the actual race car would be like much bigger. In fact, I think usually on Matchbox cars, it even lists the scale. It says it has a scale of like 1 to 72 or 1 to 60, meaning every 1 inch on here is like 60 inches on there. Speaking of scale, scale is the ratio of the fake thing to the real thing. So every 1 inch on the fake thing is like 72 inches on the real thing. And we're going to see how that's used in a variety of different cases. So first things first, we're just going to solve some problems using the cross product again. So it's the same stuff we were looking at, but some of these get a little bit more tricky. So, first problem, easy. We're just going to cross multiply like normal. So 16 times m is 16m. 20 times 5 is 100. Divide by 16, divide by 16. I think we had this problem in the last lesson. Because 100 divided by 16 is 6.25 or 6.625. 100 divided by 16 equals 6.25. Now, automatically, letter B looks funky. We've got two variables, x here and x minus 3 there. And now, if you did a different way of cross-multiplying or of doing the proportion, this is something I always caution. I didn't mention it last lesson. Let me show here. If you do what I call the fishy method, some people do this thing where they start here and they go like this and they multiply those two and then divide by that equals that. Unfortunately, the fishy, and by the way, it's called the fishy because look at it. The blue thingy looks kind of like a little fishy. The fishy method does not work for anything other than the absolute simplest proportions. The cross-multiply way works for every proportion, which is why this is the best way to do it. Watch. We're going to take this times that, and this times that. Well, we know x times 8 is 8x. So we need to take 4 times this stuff. Watch. 4 times this stuff. How would we do that multiply? The way we've done it in the past is by distributing. It's the same thing. We're going to take the 4 times the x is 4x. 4 times a negative 3 is a negative 12. And now we just have a multi-step equation to solve. There are no more parentheses. I cannot combine anything on this side. I cannot combine anything on that side. I do have variables on both sides. So here I'm going to subtract the right side by 8x to get rid of the variable on the right. Subtract 8x. I get 0 equals negative 4x minus 12. Plus 12 here, cancel. Plus 12 there gives me, move over here a little bit, negative 4x is on this side equals 12 on that side. We're going to divide by negative 4, divide by negative 4. These cancel. X equals negative 3. So all the x's, that x would be a negative 3, that x would be a negative 3. So negative 3, negative 3, that would be like a negative 6. So that's what this proportion is when x is negative 3. That's what makes this thing true. And you can only solve this using cross multiplication. Let's see another example. So we're going to draw in the multiplies. We're going to take 9 times x, 3 times this stuff, 3 times that stuff. Well, let's do that stuff. So 3 times x is 3x. 3 times a negative 4 is a negative 12. And we'll continue going. Let's see. Well, I can't combine anything on either side. So step 2 done. Step 3, get rid of the variable on the right. That's him. So if I subtract 3x minus 3x, I get negative 12 here. I get 6x here. Divide by 6, divide by 6, x equals negative 12 divided by 6 is negative 2. Last one, before you try some. Draw in the multiplies. So I need to take 8 times this stuff. And on this side, I'm going to take a 5n minus 2 times 3. So I'm going to put the 3 on the outside, 5n minus 2 on the inside. Now this is just a equation like we did in the last lesson, and the lesson before, and the lesson before. The way you get rid of parentheses is by distributing. 15n minus 6 distributing 8n plus 64. That 6 is bothering. Ooh, too big. That 6 is bothering us. 15n minus 6, which means that was a 2. Alright. Now, I cannot combine anything here. I cannot combine anything here. So I'm going to get rid of the variable on the right. That's him. Minus 15n minus 15n. Negative 6 on this side. 8n minus 15n is a negative 7n plus 64. Now I'm just solving. This is a two-step. So I have a multiply and I have an add. Get rid of the adds and subtracts first. These cancel. Negative 7n equals a negative 70. Yeah, negative 70. Signs of the same add. And divide by negative 7, divide by negative 7. N equals negative 70 divided by negative 7 is a positive 10. So when we cross-multiplied, it gave us an equation. We solved the equation the same way we did in the last lessons by getting rid of parentheses first, then combining like terms, getting rid of the variable on the right-hand side, getting rid of the other terms by adding and subtracting, getting rid of coefficients by multiplying or dividing. And there we are. So, now that we've done a few, or I've done a few, it's time for you to do a few. Here are examples E, F, G, H. Please write them down, pause the video, do them on your own. When you are ready to continue, hit play, and we will go through them together. Alright, letter E. We are going to draw the things we're going to multiply together. So we're going to take a 1 times 3g, 1 times 3g, a 2 times a g plus 5, 2 times g plus 5. Well, 1 times 3g is just 3g. That gives me a 2g plus 10. Can't combine anything on either side. I do have variables on both sides, so I get rid of the one on the right, so I have minus 2g here and there. These cancel. 3g minus 2g is 1g. And if you remember from the past, if you have 1g, that's the same thing as g. That problem is done. My variable is by itself. Letter F. Only one variable. I like it. Cross multiply. 8 times x is 8x. 3 times 4 is 12. Well, the way we get rid of this, or solve this one step, is we divide by 8 here and there. These cancel. Ooh, not 8. X equals 12 divided by 8. That does not work out to a pretty number, but it comes out to a fraction. 12 divided by 8 equals 1.5. Oh, how we miss those easy days. Back to the hard ones. Letter G. Alright, so we got to take this stuff times 5 and this stuff times by 2. So 5 times that stuff, h plus 8, and 2 times that stuff, h minus 1, parentheses, distribute. That and that gives us 5h plus 40. That and that gives us 2h minus 2. Solve. Well, I can't combine anything here or here, but I do have the same variable on both sides. I've got h's. So I'm going to get rid of the one on the right. I'm going to minus 2h to get rid of him. Minus 2h over there gives me 3h plus 40 equals a negative 2. Alright, solve. So to get rid of this plus 40, I minus 40 here, minus 40 there. These cancel out, and I get 3h equals a negative 42. Last step to solve, get rid of the multiply by dividing, and h equals negative 42 divided by 3. 42 divided by 3 is 14, and it's a negative because the signs are different, so the answer is negative when you divide. Lastly, letter H. We're going to take our 4b times 126 and our 56 times our 9. Let's do the b thingy first. So 4 times 126 is 504b, and 56 times by 9 is 504. Oh, nice. Because when we divide by 504 here, divide by 504 here, now these, you don't actually cancel them out. You don't get 0. This over here, I think I remember we talked about this before, but the reason why I'm canceling these out is because 504 divided by 504 is actually 1. 504 gives us 1. But we just don't need to write this 1 in front of the variable. That's why I kind of cancel them out, because it gets the variable by itself. It makes a 1b, and if you divide by 1, you kind of get the same thing. So this does not give you a 0, it gives you a 1. Alright, so here's a couple questions to try out of the textbook. Pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Alright, number 1 says 4 over a equals 24 over 30. Cross multiply, 4 times 30 is 120. A times 24, well, that's just 24a. Divide by 24 to get rid of the multiply. Divide by 24 there, and a equals, clear, 120 divided by, was it 24 equals 5. Number 2 says 3 over x equals 2 over x minus 6. Well, when we cross multiply here, we're going to take the x times the 2, which is 2x, and take the x minus 6 times the 3, which is 3 times x minus 6. We have to distribute here, so we take the 3 times the x, the 3 times the 6. Now we solve. So let us see, we cannot combine any like terms on either side. We have the same variable on both sides, so get rid of the one on the right. So minus 2x, minus 2x. This gives me 1x. There's 1x. Minus 18 equals 0. And then I add 18 to both sides, and I get x equals 18. Number 3 says m over 5 equals m minus 6 over 4. Cross multiply here. Let's see. 4 times m is 4m. 5 times this stuff. 5 times that stuff. Well, we distribute it. We get 5m minus 30. Now we solve. Let's see. We have nothing to combine on either side. I do have the same variable on both sides, so I subtract 5m here and there. These cancel out. We get negative 30 here and a negative 1 there. Because it's a negative, we do have to leave it here. We're not just going to erase and go, oh, it's just 1m, or it's just m. Because there's a negative, we have to keep it. And to get rid of that negative 1, we divide by negative 1. The negatives cancel. M equals, and the negatives cancel. We get positive 30. 30 divided by 1 is 30. All right, so that is 1, 2, and 3. Let's check out number 4, a little wordy problem. It says here, in example 3, suppose the seal weighs 260 pounds. How much food would the seal be fed per day? So looking at example 3 from the textbook, it says each day the seals at the aquarium are fed 8 pounds of food for every 100 pounds of their body weight. That sounds important. 8 pounds of food for every 100 pounds of body weight. I'll call it W. The seal at the aquarium weighs 280 pounds. How much food should she eat per day? Well, here it says, suppose the seal weighs 260 pounds. So, you notice how I put pounds of food and pounds of weight? Because if you just put down pounds and pounds like this, it wouldn't make any sense on where this pounds go and the pounds of food go. So you need some other label besides just pounds and pounds and pounds and pounds. So that's when we say pounds of weight and pounds of food. So if this is pounds of food, pounds of weight, this seal weighs 260 pounds. Is that the food weight or the weight of the animal? Well, it's the weight of the animal. So that's the question. How much food? How much food should the seal be fed? So let's cross multiply. 260 times 8, big number. 260 times by 8 is 2080. 100 times by x, easy. Divide by 100, cancel. Divide by 100, x equals, I can do that in my head, 20.8 pounds of food. So that animal will eat almost 21 pounds of food every day. Example 2. Now, here we're talking about those scale problems, those scale maps, scale models, scale drawings. You see in the picture here we have a scale drawing of this World War II plane that was nicknamed Spitfire. So it says, above is a 3-inch to 32-foot scale drawing of a World War II plane named Spitfire. So that means every 3 inches on the drawing is 32 feet in real life. If a man is normally about 6 feet tall, how tall would he be in the drawing? Okay, so whenever you're given a scale problem, the scale is the first half of the proportion. 3 inches, 32 feet. Now remember back in our vocabulary, scale is the ratio of the fake thing to the real thing. So this 3 inches is the fake, it's the drawing. The 32 feet is the real plane, the actual airplane. So inches and feet. If a man is normally 6 feet tall, well, is that 6 foot tall man the fake height of him or the real height of him? That 6 foot tall is the real height. We don't know how tall he would be in the drawing, in the fake thing. So that's where our cross multiply comes in. So let's see, 3 times 6 is 18. 32 times x is 32x. Solve. Divide by 32. Divide by 32. X equals 18 divided by 32. So 0.5625. We'll call it 0.56. And that would be inches. So So in our picture, a man would only be about half an inch tall. So 3 inches is 32 feet. Our man would be about half an inch tall. There. Letter B. If we could see a different view of the same plane, the wings would be 3.75 inches long. How long would the wings be on the actual plane? Well, to answer this, first off, we need to have our scale again. Scale's right there in the picture. 3 inches is 32 feet. 3 inches is 32 feet. So 3 inches on the fake is 32 feet on the real. So the wings would be 33.75 inches long. Is that 3.75 inches the actual plane, or is that in the picture? If not sure, keep reading. How long would the wings be on the actual plane? We don't know the real length. The real goes on the bottom. We don't know that, so that's going to be the variable, which means this guy up top has to be the fake, the 3.75. So now we cross multiply. X times 3 is 3x. 32 times 3.75. 32, 3.75 equals 120. Solve. Divide by 3. Divide by 3. X equals 40. So the wings of that plane would actually be 40 feet in real life. The scale goes first, the other information goes second. Okay? Here is letter C. I'll read it to you, then you copy it down and do it on your own. It says, a map has a scale of 1 centimeter to 12 kilometers. The distance between two cities on the map is 6.8 centimeters. Estimate the actual distance between the cities. Pause the video, do it on your own. When you're ready to continue, hit play. Okay, so you should see 1 centimeter to 12 kilometers. That is the first, that's the scale, that's the first part of the proportion. So centimeters, kilometers. The distance between the two cities on the map is 6.8 centimeters. Now, is the map the real distance, or is that the fake distance? Well, it's definitely the fake distance. The real distance between these two cities is not 6.8 centimeters. So the kilometers estimate the actual distance. We don't know. So we're going to cross multiply here. And let's see, 1 times x is just x. 12 times 6.8. 6.8 equals 81.6. And the label is kilometers. So between those two cities is about 81.6 kilometers. Again, in setting up proportions, labels are the key. Make sure you are putting down your labels. Here is number 6 from your textbook. Please do this problem right now. Pause the video, hit play when you're ready to continue. Okay. It says the ship model kits sold at a hobby store have a scale of 1 foot. Okay, so they give us a scale. 1 foot to 600 feet. I see a problem. Our labels are the same. Just got to remember that the top number is the fake. The bottom number is the real. So since it's feet and feet, no matter what they give us, we got to make sure we're putting the fake thingy up top and the real thingy on the bottom. So it says a completed model of the Queen Elizabeth is 1.6 feet long. So the completed model is 1.6 feet long. The model is the fake thing. So this fake thingy goes up top. Estimate the actual distance. We don't know that. So the thing we don't know is the variable. Now we make sure we have it set up correctly. So we now cross multiply. So x times 1 is 1x, or just x. 600 times 1.6, 600 times 1.6 equals 960. And of course the label is going to be feet because everything was feet. So the actual ship is 960 feet. Summary. How do you solve problems using cross products? Honestly, I'd just say multiply the diagonals, then solve. Then solve the equation. And for homework, we got pages 171 and 172, numbers 2 through 22 evens, and 33 through 35. This has been lesson 3.6. Thanks for tuning in.